Alright, Chapter 18, Problem 7. We have a 50-gram ball of copper with a net charge of 2 microcoulombs. What fraction of the copper's electrons has been removed? Okay, so each copper atom has 29 protons, and copper has an atomic mass of 63.5. The atomic mass of 63.5 means on average copper has 29 protons plus 63.5 protons plus neutrons, giving it an atomic mass unit of 63.5. It also means that copper has a mass of 63.5 grams per mole, right? And so if we want to know what we really want to know is how many electrons there are, so we can figure out what fraction of those electrons represent the minus 2 microcoulombs that we have to take out of the copper. And we start by figuring out how many copper atoms there are, right? All right, so we have 50 grams of copper times, all right, a mole per 63.5 grams, right, is going to give us how many moles we have of copper times 6.02 times 10 to the 23rd, right, particles or atoms per mole, right, Avogadro's number. So this gives us how many atoms times 29 protons per atom, right, times 29 protons per atom, and this is going to give us the total number of protons, which in a neutral bit of copper corresponds to the total number of electrons. So what does this look like? 50 divided by 63.5 times 6.02 times 10 to the 23rd times 29, right, times 29, and that gives us 1.37 times 10 to the 25th protons. 1.37 times 10 to the 25th protons. That is also how many electrons a neutral bit of copper would have. So, how many electrons are we talking about having to remove? All right. So we have to remove minus 2 microcoulombs of electrons. So minus 2 times 10 to the minus 6 coulombs times an electron per minus 1.6 times 10 to the minus 19th coulombs equals, okay, 2e minus 6 divided by 1.6 e minus 19, 1.25 times 10 to the 13th. 0.25 times 25 times 10 to the 13th electrons, right? And I'm going to add up here times 1 electron per proton, right, to get us to 1.37 times 10 to the 25th electrons. So at the end of the day, the real question is, right, what percentage of electrons are we talking about? And so the fraction of electrons removed is 1.25 over times 10 to the 13th electrons divided by 1.37 times 10 to the 25th electrons equals 9 times 10 to the minus 13. 9 times 10 to the minus 13 is a fraction, right? And if we want that in percent, multiply by 100%. And so this is 9 times 10 to the minus 11% of the electrons have to be removed in order to give the copper ball a net charge of plus 2 microcoulombs. And that's it for problem 7.